There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t equals 7te to the power of cosine of t, cubic feet per hour, where t is measured in hours since midnight. Janet starts removing snow at 6 a.m., t is equal to 6. The rate g of t in cubic feet per hour at which Janet removes snow from the driveway at time t hours after midnight is modeled by g of t equals 0 for 0 is lesser than or equal to t, which is lesser than 6. G of t equals 125 for 6 is lesser than or equal to t, which is lesser than 7. And g of t equals 108 for 7 is lesser than or equal to t, which is lesser than or equal to 9. How many cubic feet of snow have accumulated on the driveway by 6 a.m.?
So the total rate at which snow accumulates on the driveway is going to be the rate at which snow falls minus how much snow Janet is removing. So that would be f of t minus g of t. And since in this case g of t is equal to 0, it's just going to be 7t e to the power of cosine t. So now I want to find how much cubic feet of snow accumulates on the driveway by 6 a.m. So first, we can start by graphing the function. So the function will look somewhat like, wait, it's a different color. It'll look somewhat like that. And our units are volume per time by time, because this is in cubic feet per hour, and so that's cubic feet is a volume per time, and it's going across by time, so that's time. And we want to find the area under the curve, because the area under the curve, if we find the area under the curve of this, we will have the units, the axes will be multiplied by each other effectively. So that would be v volume over time times time, which will give us just the volume in cubic feet per hour. So in order to find the area under the curve, what we do is we take infinitesimally small time units, which is called dt. And when we do that, essentially we're taking the definite integral of it from 0 to 6, because we want to find it between 0, which is 12 a.m., to 6 a.m., of the rate of change with respect to time, which is the same as the integral from 0 to 6 of the function, which will give us 142.27 cubic feet.
Find the rate of change of the volume of snow on the driveway at 8 a.m. So the problem is asking us to find the rate of change of the volume of snow on the driveway at 8 a.m. Or, in other terms, it's asking us to solve r of 8. We know that this is going to be equal to f of 8, which is the rate of snow accumulating on the driveway, minus the rate of what Janet is removing the snow at, which is g of 8. So then, we already know that f of 8 is going to be equal to 7 times t, in this case it's going to be 8, times e to the power of cosine of t, which is again 8. And then we already know that g of 8 is going to equal to 108, because 8 falls in the interval from 7 to 9, and the piecewise function tells us that the rate is going to be 108. So now we just have to subtract these. So f of 8, is going to be equal to 56 e cosine of 8 and then minus g of 8, which we know is 108. This gives us an approximate answer of about negative 59.583. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain 0 is lesser than or equal to t, which is lesser than or equal to 9.
So the problem wants us to find h of t, where h of t is a function of how much snow Janet has removed from the driveway between 0 and 9 a.m., or 12 a.m. and 9 a.m. So along this interval. So first we want to find what h of t represents. So we know that we have the function g of t, which is how much snow Janet has removed from the driveway. So from 0 until 6 a.m., Janet removes 0 cubic feet of snow. From 6 a.m. to 7 a.m., Janet removes 125 cubic feet of snow per second, or per hour. And from 7 a.m. until 9 a.m., Janet removes 108 cubic feet of snow per hour. And this is in feet cubed per hour. So, so we know that g of t is essentially the rate of change of h of t. So in other words, g of t is the derivative of h of t. Right, so now if we want to find what h of t is at any time along t, we could take the integral, we would take the integral of g of t. So, let's say the integral from, we'll start at 0 to any time t of g of x d of x. And the reason we changed the variable is because we're integrating by a different variable because we have time here, and this is just a function in relation to x. So if we use the fundamental theorem of calculus, we know that that will equal the integral of g, which will be h, of t minus h of 0, like that. And then if we just want to solve for h of t, we can move this to this side by adding h of 0 to both sides. So we get that h of t is equal to h of 0 plus the integral from 0 to t of g of x dx. Now this would work if h of t was not piecewise, but since it is piecewise, that means that it will have different intervals at which it changes. So we have to solve h of t at different intervals. So first we're going to start with the interval from 0 to 6. So for this interval, you have that h of t will be equal to pretty much what we have here. So h of 0 plus the integral from 0 to t of g of x dx. So we know that in this interval, g of x will always be 0. So we can simplify this so that we also know that it starts out with no snow on the driveway. So the amount of snow on the driveway at time t equals 0 will just be 0. that will be 0 plus the integral from 0 to t of g of x, which is 0, dx. And that will just be 0. Now we go to the next interval, which is from 6 to 7. So from this interval, we have h of t equals, and in a similar way to this, we do the same thing, except we're not starting at t equals 0, we're starting at t equals 6. So this will be h of 6 plus the integral from 0 to t of g of x dx. So we know that at h of 6, we still have no snow on the driveway. And we also know that g of x in this interval will be 125. So we can rewrite this as h of t equals 0 plus the integral from 0 to t, or sorry, this should be 6. Because we're starting at 6. So from 6 to t of 125 dx. And then if we use the first fundamental theorem of calculus, we can simplify this into 125x from 6 to t, which will equal 125 times t minus 125 times 6, or 125 times t minus 6, if you factor out the 125. So now we'll do the same thing again, but now we'll go from the interval of 7 to 9 a.m. So in this interval, we have h of t is going to be equal to h of 7, because that's our starting point, plus the integral from 7 to t of g of x dx. So now we have to solve for what h of 7 is. So to solve for that, we take this function and we plug in 7. So if we do that, you get h of 7 is going to be equal to 125 7 minus 6, which equals 125. So now we can rewrite this as h of t equals, h of 7 is 125, so 125, and g of x on this interval will always be 108. So that's plus the integral from 7 to t of 108 dx. And then we can solve for that, so that will equal 125 plus 108x from t to 7 using the first fundamental theorem of calculus. So that's 125 plus 108 times t minus 7. So now that we have all of the values of our function at the different intervals, we can write this as a piecewise function. So in order to do that, we take h of t so if we take the first value, which is 0, from this interval, so 0 is less than or equal to t is less than 6, and we take the next value, which is 125 times t minus 6 from 6 is less than or equal to t is less than 7. And then we take our final value, which is 125 plus 108 times t minus 7. It's less than or equal to 9. So this, oh well. This is our final piecewise function.
How many cubic feet of snow are on the driveway at 9 a.m.? So the problem is asking us how much cubic feet of snow is accumulated on the driveway at 9 a.m. So we know that the snow is falling at a rate of f of t. And to see how much snow has accumulated on the driveway, we can take the integral from 0 to 9, because this tells us how much physical cubic feet of snow has accumulated on the driveway, as we've seen from previous solutions. So we can take the integral of 0 to 9 of f of t. So then we also have to subtract the rate of which Janet is removing the snow, which is described as g of t. So minus g of t. And then times dt. So then if we split the integral, then we get 0.9 of f of t dt minus the integral of 0 to 9 of g of t dt. And in the previous solution, we found out that the integral of g of t is actually equal to h of t. So this actually simplifies to 0 to 9 of f of t dt minus h of 9. And h of 9 describes how much snow Janet has physically removed from the driveway, while g of t describes the rate, and the integral of the rate will give us the amount. So solving this equation, we get the integral of 0 to 9, and then plugging in f of t, we get 7t e to the power of cosine of t times dt minus h of 9, which is going to equal 125 plus 108 times t minus 7. And h of 9 equals this because if you remember from the previous problem, from the time frame of 7 to 9, we solved h of t to be 125 plus 108 times t minus 7 in that time interval. So we can just plug that in for h of 9 here and solve this equation to get the answer. Well, we'll have to plug in 9 for t in here, and then now we can solve it. This gives us an approximation of 26.335 cubic feet.